Today I have chosen the topic basics of sets. You can see the page number 84 in your textbook. There is the sets 1. You can see we are using the different symbols in the sets like this epsilon, and it represents belongs to or is a member of, then 5, then this subset, then this intersection, then this union, xi and complement of a, and n of a. These all things one by one we will understand. Before starting, I want to inform you I have already made a video on the sets. Please watch that video. Definitely, you will learn many things from that video. Now, here we go. Sets. What is the definition of the sets in mathematics? We can say it's a collection of objects described by a rule or a list, or simply well-defined collection of objects. Before starting this video, I want to inform you that I have already made a video on the sets. Please go through that video, watch that video, and definitely you will learn many things from that video. Here we will start the representation of the set. Representation of set. First thing we should understand, always sets are represented by the capital letters. Capital letters like A, B, C, etc. For example, I have the set A is equal to 1, 2, 3, 4, 5. If I will write small a equals to 1, 2, 3, 4, 5. This is the incorrect way. Why this is incorrect way? Because sets are represented by the capital letters. And next point is that all elements in a set, or all members in a set, are enclosed by braces, that is curly brackets like this. So we should remember all the elements or all the members in a set are enclosed by this curly bracket. If I will write a is equal to like this 1, 2, 3, 4, or I will write a is equal to long bracket 1, 2, 3, 4, or I will write a is equal to 1, 2, 3, 4. These all are incorrect ways, because we should write here the curly brackets. We should write all the elements within the curly brackets, enclosed by the curly brackets. These sets are represented or denoted by the capital letters. And next is all elements in a set are enclosed by the braces. There should be the curly brackets on the starting and at the end of the set. And the elements or members in a set are separated by the bracket, this commas. You can see here I should place the comma. If I am not placing the comma, then it's not correct way. I cannot write like this 1, 1, 2, 1, 2, 3, 4, 5, 6. I cannot write this. I should place the commas between the elements of the set. This was about this. Now you can see let's take the example of a set X. I have in the set X I have elements A, B, C and D. I will write A belongs to X, or this means belongs to, that's A is an element of set X, B is an element of set X, C is an element of set X, D is an element of set X. If I will write E is not an element of X, or I can say E does not belong to X. F does not belong to X. So this means, this shows that A is an element in X, B is an element in X, C is an element in X, or I can say C is a member of, or C belongs to, A belongs to. You can use anything. So this symbol is belongs to or is a member of. This means does not belong to. Here I am writing E does not belong to X. That's E is not in the set X. Now next you can see I will take here the two elements. Y is equal to A, B. You can see every element of Y is also present in X. That's all the elements of Y are present in set X. So I can write Y is a subset of X. Why? Because every element, or I can say all elements or all members, every element of set Y is also element of set X. Now one more thing, X is not a subset of Y. You know why? Because every element of X is not in Y. You can see here C belongs to X, but C does not belong to Y. So we can say here, when every element of a set is also present in another set, then it becomes the subset of that set. Here you can see X and Y are the two sets. In X, the elements are A, B, C, D. In Y, the elements are A and B. You can see every element of Y is also present in X. So Y is a subset of X. This symbol is subset. Y is a subset of X. And here you can see X is not a subset of Y, because every element of the X is not the element of Y. That means all elements are not present, all elements of X are not present in Y. We can write X is not a subset of Y. Why? C belongs to X, but C does not belong to Y. Now this is the concept of subset. Now intersection. This symbol is intersection of sets. What is the intersection? We will understand here. If A is the set 1, 2, 3, 4, 5, 6, and B is another set and its elements are 2, 5, 7, 9, then I need to find A intersection B. What is that? A intersection B means common elements of set A and set B. That is, those elements which are present in both the sets A and B. You can see what is that. 2 is here present, here is 2 present. Here is 5, here is 5. So I can write here it is 2 and 5. So A intersection B means those elements which are in set A and set B. We need to check here 2 and 5 are present in both the sets. So the set 2, 5, there are two members only, forms the A intersection B. Now one more thing is there, union. We have A union B. It means all elements of A and B, all elements of set A and set B. How to write that? You can see here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We are writing first the elements of A. Then we will write the elements of B. 2. If I will write here 2, it is not correct because 2 is already here. So we should not repeat the set. We should not repeat the element in the set. So I cannot write the 2. Then 5. 5 is already written here. So I cannot repeat here 5. If I will repeat the 5, that's incorrect. Now after 6, it is 7. 7 is not there and 9 is not there. So what is A union B? All elements of A and B. But one thing we should remember, the elements should not repeat. If we will repeat the elements in the within the curly braces, that makes the incorrect sense. So A union B is simply what? It is the all elements of set A and B. And sometimes we have P intersection Q. That means all those elements which are common in set P and set Q. Sometimes we will have P union Q. It depends upon the set. It depends upon the set. What is the name of the set? Similarly, simple in a simple way, we should understand this intersection, this union, all common elements or the union or the intersection, and all elements of A and B is the union. Now, next I will give you the example. If in set A I have 1, 2, 3 elements, in set B I have 2, 3, 1 elements, in set C I have 3, 1, 2 elements. You can see, irrespective of the order of the members of the set, you can see every set has the same elements, same number of elements and same elements. So I can write set A is equal to set B is equal to set C, set A is equal to set C. I can write set A is equal to set B is equal to set C. You have to understand when the sets are equal, when in a set there are common, there are same elements. It does not depend upon the order of the elements. Here 1 is written first, here 2 is written first, here 3 is written first. No, we should check the numbers, the members. Here 1 is there, 2 is there, 3 is there. So A is equal to B, B is equal to C, C is equal to A. Now next, the complement. First we will see the null set. We have the null set or the empty set. Null or empty set. Empty set. What is that? Null set and empty set is the set in which there is no element or no member. Or no member. That's called the empty set. And this empty set is denoted by like this, or this is denoted by this Greek word, it is phi. So phi denotes what? Empty set. For example, I will give you the example here. A is equal to A, B, C, and B is equal to D, E, F. Now A intersection B, what is the common element? How many common elements are there in A and B? There is no common element. A, B, C, here D, E, F. So I will write here phi. That's null set. That's empty set. So A intersection B is here the phi. Or I can also write the curly braces, and there should be no blank curly braces. So A intersection B is phi. That's empty set. Here you can see there is no common element. That's why we can write here empty set. Next we will see n of A. Sometimes n of A, sometimes n of B, sometimes n of A intersection B, sometimes n of A union B. What is this n? N of A. It means number of elements in this set. Number of elements or number of members. That means we have to do counting. We have to count. For example, in set A there are A, B, C and D. N of A is equal to 1, 2, 3, 4. We should write only the 4. In the set B, it is C, D, E, F, G. You can see N of B is equal to, we will count here 1, 2, 3, 4, 5. So N of B is 5. This is also called the cardinal number. Cardinal number. Cardinal number of the set is the number of elements in the set. Now I will find A intersection B. What is A intersection B? Common elements are CD, CD. So I will write CD. So what is N of A intersection B? That is, this is the set. How many elements are there? 2. So I will write here the 2. Now one more thing. A union B. All elements of A and B. That's A, B, C, D. First I will write the elements of A. That's A, B, C, D. Now I will write elements of B. C, D. C, D is already written. So I will start with E, F, G. So N of A union B. That's how many elements are in this set A union B. 1, 2, 3, 4, 5, 6, 7. So 7 is here the answer. Now next is the universal set. Universal set. And this is denoted by this symbol. This is xi. It's a Greek symbol. This is xi. So this is universal set. What is universal set? It is a set containing all the elements being considered in a particular problem. So set of all elements being considered in a particular problem. Now how to understand this? If I am writing A is equal to A, B, C, D. Here A is what? Here you can see A is the set of first four letters of English alphabets. Here the universal set will be all alphabets, because we are talking about the letters of alphabets. That's why here the universal shall be what? All alphabets. For example, if set B is equal to 1, 2, 3, 4, we are talking about the numbers, so here the universal set will be all numbers. All numbers. For example, sometimes set C is equal to, it's red, yellow, white. So here the universal set is, we are talking about the colors, all colors. So what actually is the universal set? Sometimes universal set will be given in the question. That at that situation we have to consider that universal set. But sometimes the universal set is not given in the question. Here A is equal to A, B, C, D. Here what is the universal set? Universal set is all letters of the English alphabets. Here B is 1, 2, 3, 4. These are the numbers. So what we will do here, we will consider all numbers as the universal set. Here C is the set of colors. Here it's not given the universal set. How many colors are there in the universal set? So what we will consider? We will consider all the colors will be the universal set. Now coming to the next point, that is the complement. What is the complement? You can see here A, in set A there are four elements, A, B, C, D. What is complement of A? A dash, this is the complement of A. It is the set of all members from the universal set which are not in A. You can see what is the universal set here. Universal set is all English alphabets. And in the universal set, what are how many elements are from A? A, B, C, D. What are the remaining? E, F, G, H, etc. till Z. So this is the complement of A. For example, I am saying you this is universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set B is 3, 4, 5, 6, 7. What is the complement of B? Complement of B is those elements of the universal set which are not in B. You can see here 1 is not in B, 2 is not in B, and 8 is not in B, 9 is not in B, 10 is not in B. So this is the complement of B. What are Venn diagrams? Sets can be shown in a diagram. These are called the Venn diagrams after the name of mathematician John Venn. So what are actually the Venn diagrams? You can see here, I will give you the example. For example, I have 1, 2, 3. I will keep them 1, 2, 3 here in the circle. So this is a kind of Venn diagram. I have A, B, C, D. I will keep them in the circle A, B, C, and D. I will name it, this is A, like this, and this is B. Here this is B, here this is A. Now you can see these circles represent these numbers. Now how to represent the Venn diagram? What is the perfect rule? First we will understand how to draw the Venn diagram. There is a perfect rule. I will take the example of set P. P is equal to A, E, I, O, U. Now how to show this information in a Venn diagram? Always we have to draw the rectangle. This xi represents the rectangle. This is the universal set. So in the universal set I will show this P. This P. How many elements are there in P? A, E, I, O, U. Now this is over. Now if I have set S is a subset of set Q. Show this information in a Venn diagram. S is a subset of Q. I want to show this information by Venn diagram. So what I will do, I will draw here the Venn diagram. First, I will draw the universal set, that is Xi. Then since every element of Q is an element of S, so I will draw here the one circle, then another circle. Since S is a subset of Q, so I will write here this is S and this is Q. What does this represent? It represents S is a subset of Q, that all the elements are present in the set Q. All the elements of S, all the members of S are present in the set Q. That means S is a subset of Q. Now next we will see how to show the intersection of sets in a Venn diagram. If P intersection T, this information I have to show on a Venn diagram. I will draw first the rectangle. This is the Xi. Then there is an intersection. So I will draw two circles overlapping. The two circles will be overlapping. This is P, this is T. You can see this portion. This portion belongs to P and belongs to T also. So this portion is the intersection, P intersection T. Now I will give you the example. If in a set P I have 1, 2, 3, 4, 5, and in set T I have 3, 4, 6, 7, 8. How to represent this information in a Venn diagram? I will draw here the rectangle. What is this? This rectangle represents the universal set, and here you can see here there is an intersection 3, 4, 3, 4. So I will make two circles overlapping to each other. This is P, this is T. In the intersection part there is 3, 4. Now I will write in the set P 1, 2, 5, 1, 2, 5, 3, 4 is written. In the set T I will write 6, 7, 8. 6, 7, 8. So this is intersection part 3, 4. P intersection T is 3, 4. And in the set P there is 1, 2, 5. In the set Q T there is 6, 7, 8, and this intersection part. Now here you can see what is the union. This was intersection. Now see, P union T is whole portion. Now P union T, all elements, that's from here, that's 1, 2, 5, 3, 4, 6, 7, 8. This is the union part. All the circles, all the elements that are written in the circles, that are written in this intersection part, these are all what? They are all P union T. P union T is 1, 2, 5, 3, 4, 7, 6, 7, 8. Next is the complement. How I will show complement in a Venn diagram. This is the universal set Xi, and this set is A. You can see this set is A. This portion is A dash, that's complement of A. This whole portion. Once again I will show you. If this is the universal set and this set is set B, the complement of B dash, that is B dash is complement of B, will be this portion. All the elements of universal set that are not in B, that is the complement of B, that is B dash. You should understand those elements which are not in B is the complement of the set B, that's B dash. Here we have n of A intersection B is equal to n of A plus n of B minus n of A union B. If we know, we have how many variables? 1, 2, 3, 4. If we know the 3, we can find the third one. And one more is there. This is one. This is of intersection n of A union B. Now I will transpose this. A union B I will write here. A union B is called n of A plus n of B minus n of A intersection B. Here you can see when it is intersection, here is union. When here is union, here is intersection. These are the two formulas that we are using in the sets 1. So please watch the video, the first video I have made on the sets. There I have solved a few examples. Thanks for watching this video.